Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering. So in this video, I'm going to discuss about how we're going to designing the charts and graph for better visualization of any kind of application. So normally before going to see that the data what we are going to be shown for our application, so first we have to be categorize the data into different categories. So normally the data will be of different types like quantitative data, discrete data, continuous data, and then categorical data. So before understanding the visualization what are going to be shown, so you may have to must understand what type of data it is and then how are going to be visualized and what are the relationships among the data and how what kind of best suitable visualization is going to be considered for any kind of application, how to be check it out. So normally the data will be of two types. Just now what I said should be quantitative, discrete, and then continuous and categorical. So quantitative means that so the data that can be counted or it may be measured, and what are the values are there that should be in numerical form. And discrete means that so the data should be in numerical form, which should be have a finite number of possible values. So example is that number of employees in the office like this, and number of players in the game like that. And continuous, so continuous means that so data what is going to be measured should have a value within the range, and like be the example may be the rainfall in a year. And categorical, so that means that the data which can be sorted according to the group or category, and example may be the types of products sold like that. Okay, so normally the data should be of quantitative one. So the data quantitative means that the data that should be counted or it may be measured. So all should be have some numerical values like suppose weight, so that may be expressed in form of kgs, height that should be in the form of centimeters. So similarly next one should be discrete data. So the discrete data means which should be have numerical value, and it should also be finite number of possible values like a number of employees in the office. Let it be 100 employees like this. And continuous means the data which is going to be changed according to the period of time. So example, rainfall in a year. Suppose the rainfall may comes in month of February, you will note it, and again should becomes August, and then again September like this. We can the periodically times of an rainfall what we're going to measure continuously, and it will be the score of in India. So it should be going to be changed over our time to time. What should be like that. And next one is that categorical. So categorical means where the data can be sorted according to the group or category. That may be the types of products sold. And what kind of relationship we can able to establish between them should be data relationship like nominal comparison. So nominal comparison means it should be a simple comparison of quantitative values of the subcategories like number of visitors in various websites. And time series, so time series means that these can able to make changes in the value of consistent metric over the time. So that means monthly sales. And the correlation means this is the data which should be of contain two or more variables, so that should able to demonstrate a positive or negative correlation to each other. And example may be the salaries according to the educational level. And ranking should also be considered, which is going to be shown two or more values which is going to be compared to the relative magnitude. So example like historic weather pattern and rank from hottest months to the coldest one. And next one should be the deviation. So this is another kind of relationship, how the data is going to be divided with the other kind of input data what are going to be subjected here. And this means how the data points should be related to each other, and particularly how far for any kind of given data input, like amusement park tickets sold on rainy days and then regular days, like this. And next one should be the distribution. So here which is going to be shown the data distribution often around the central value, like height of players and a basketball team, and the part to whole relationship, which is going to be show a subset of data compared to the larger value and percentage of customers purchasing the specific products. So here these kind of relationships we have to be considered. So nominal means we can able to compare the quantitative values of the different categories, like number of visitors in the website, like this one and the example of that. And next one is time series. So time series means here the data is going to be changed with respect to the time. So example what I'm told here is that monthly sales of any particular product. And correlation, so correlation means this is the data where you can able to show two or more variables and on positive or negative correlation to each other. And ranking is that which is going to be shown two or more values comparison and to each other in relative magnitude. And next one is the deviation. So here we can able to show how the data is going to be related with each other, and then particularly in any uh, for making the difference between them. So example may be the amusement park ticket that is going to be sold in month of rainy and then regular days. And next one should be the distribution. So here how the data is going to be distributed often around the central value, and which may be the example may be the height of the players in the basketball team. And next one should be part to whole relationship. So here it may be a subset of data that is going to be compared as a whole, where the percentage of customers purchasing the products. And next one should what are the different types of charts and graph for making the better visualization. So first one should be the bar chart, pie chart, line chart, area chart, scatter plot, bubble chart, and heat map. So these are the different types of visualizations where you can able to show the data for any kind of application. And next, very first one should be that is bar chart. So bar chart should be very versatile one, and this is going to be shown the data over the time, and at the same time where you can able to compare the different categories, or you can able to parts as the whole also as well. So normally this bar chart should be of different variations. So it should be of vertical fashion and then horizontal fashion. So in vertical one, so I'm showing this page views by month. So in x-axis I'm going to be consider this months in an year, and number of views of this month I'm going to show along the y-axis. So similarly we can able to same thing what can I able to represent in the horizontal fashion as well, like so here I'm showing this education information, and then entertainment number of views, and the number of through leadership how many views, like this the content published by the different category. So in vertical one, so here it should be the data should be in chronological order, where the visualization of negative values below the x-axis may appear. And for the horizontal, the best use for the data with the longer categorical labels. So these are the some of the variations among this bar chart and pie chart. And some other kinds of bar charts may also available, like stacked bar chart and 100% stacked bar chart. So when it comes to this stacked bar chart, so here the bar what I'm going to be considering in this one is going to be categorized into different proportions. So with respect to the data, suppose the bar is going to be shown, so email marketing and then little bit color show like organic search, and then should be like paid search like this. So the bar is going to be segmented into different uh, variables. So normally this stacked bar chart is going to be used to compare the multiple part to the whole relationship. Okay, so and this where the data should be in the form of discrete as well as the continuous one, where you can also represent it in the form of horizontally and vertically as well. And when comes to this 100% stacked bar chart, so where this bar size should almost all matches with the 100%, and then it should be useful percentage distribution of subcategories like this. Suppose here also the bar should be is going to be divided into different segments of each one. Like this should be the through leadership, and this one through under entertainment, and this one going through the educational information. So, but what is the difference between the stacked one and 100% stacked one is that, so here the size of the bar may be vary here, and it should not be varied. So all the time it should be matches with the 100% of the percentage of the data. So what are the some of the best design practices? What should be considered for designing the bar chart means? So for the first thing, use the horizontal labels so instead of vertical labels. So if I'm going to mention like this, this should not be a preferable one. So all the time the data what I'm showing this label should be horizontal one. So to avoid this steep diagonal and vertical tab should be of difficult to read. And next one should be the space bar should be appropriate. Okay, so equal maintenance should be maintained here, like suppose it should be 1 inch and this should be 1.5 inch like this kind of thing may not be suitable one. And the distance or space between the bar should be equally maintained. Most preferably it should be half inch. And next one should be start with y-axis value at 0 here. So all the time we have to mention 0, which is going to be start of x and y axis. It should not be preferable some other values. So where the 0 is going to be truncates the bar and does not accurately reflect the full value. And use some consistent colors, don't use of different colors, like use one color for one bar chart. So all the time we can able to use that accent colors to highlight this significant data point as well. And next design practice is that organize the data properly or appropriately. So where the data is going to be arranged in alphabetical sequential by value. So suppose if I'm going to consider this, so where this labeling should be in zigzag order, where it is better convention is that all the time you have to mention in the sequential or maybe in alphabetical order. So these are the some of the design practices what you have to be considered for designing the bar chart. And next one should be this pie chart here. So the pie chart is going to be used for mainly for marketing or for making part to whole relationship or part to make comparisons with both the discrete and continuous data, and this should be the most impactful of the small data set. And so the variations of pie charts may are available, like standard pie chart and then donut pie chart. So standard pie chart is going to be shown the part to whole relationship, whereas this one should be the stylistic variation that enables the inclusion of the total value of the design element should be considered here. So normally this pie chart should be one of the most popular one, and then however some data visualizations it should be the most preferable one when I'm going to represent the data in the form of percentage values and percentage composition. So we can also find this difficulty making this angles, and it should be also very less effective when compared to the previous one. So what should be the design practices? What should be considered for that is that, so visualize more than 5 categories is the one. It is not suitable when we're going to consider more number of categories if I'm going to consider. Okay, so why? Because it should be difficult to differentiate between the smaller values, and then it should be also be depicting too many slices, which is going to be decrease the impact of visualization. And if needed, you can also group so many values or any other miscellaneous category as well, but make sure that it does not hide interesting or significant information. And don't use this multiple pie chart for the comparison. So normally slice sizes should be very difficult to compare side by side, and use the stacked bar chart instead as well. Okay, so some application it should be good for pie chart, and some application should be good for bar chart. So make sure that all the data should be up to 100% equally. Don't what is the percentages we're calculating, that should not be below 100%. So it should be almost all equal to the 100%. Okay, so all the time we have to verify that the values what I'm going to be considered, so that should be matches with the 100%, and it should be matched to the corresponding, all the sum of this, all the segments should match with the 100%. And next one should be this order slices correctly, because there are two different ways of ordering the sections, so which is going to be made when to aid comprehension. So like either you have to follow in clockwise or anti-clockwise direction. Okay, so don't use in different forms of ordering of segmentations of the pie chart. So place the largest section at the clock going to the clockwise, place the second next highest section at the clockwise direction, or I can able to make use an anti-clockwise direction also. And next one is that line chart. So line chart is going to be used when I'm going to show this time relationship with the continuous data. So normally this may be helpful to show the trend, and then acceleration, declaration, and volatility. So normally this line chart is going to be shown most of the places and some of the applications like cricket scores matches, and then mostly are going to see in that line chart between the Indian, Pakistan, and India, Bangladesh, like this. So like what should be here, so all the time the line is going to be established with respect to the time here. Okay, and so this is the example is going to be shown through the direct marketing views by date. So this line chart should also going to have some of the design practices. So include 0 as baseline if possible. So otherwise it should not be considered one. Maintain 0. So it is also one of the design practice of previous thing. And we can also be include the baseline, because a line chart does not have to start as 0 baseline, so it should be include if possible if all the relative small fluctuations in the data are the meaningful, or you may be able to truncate the scale, showcase these variances. And next one should be don't plot more than the 4 lines. So that means if you need to display more, break them out into separate lines before the comparison. Okay, suppose this is the line chart what we're going to obtain. Suppose I want to make comparison. At the time what I have to do, so I have to make the separating each and every line, then only have to make the comparisons. So that is the design practice you have to be follow. Suppose if you need to display more, break them out into some of the separate charts for the better comparison. And next one should be use solid lines. Solid lines means that so the dashed and dotted lines can be distracting. So okay, so all that to make use, the line should be a perfect one. So the dotted line should not be considerable for drawing this line chart. And next one should be labeling the lines and directly. So that means so this may be able to let the leader quickly identify lines and corresponding labels instead of referencing a legend. Let me be, we are going to have apples, bananas, and oranges. Uh, so what I'm going to do, label the lines separately. So here uh, I'm going to mention this oranges through red line, and bananas through blue line, and pink is through apple line. So I'm just mentioning here. This is not the good way of mentioning of line chart. So what is this line meant for? We have to mention here. And next one should be use the right height. So that means plotting all the data points to the line chart takes appropriately 2/3 of the axis of the total scale. So what is the line chart we have drawn? So that should be matches with 2/3 of the plot of the graph. So these are the some of those design practices what have to be considered for the line chart. And next one should be this area chart. So area chart mostly depict the time series relationship, but they are different from the line chart. What they're going to be represents here should be the volume here. So some of the variations of the way area chart may be uh, area chart and stacked area chart and 100% stacked area chart. So very first thing should be this area chart. So it should be best used to show or compare more quantitative progression over the time. And the stacked area chart it should be best to visualize part to whole relationship, helping to show each category contributes to the cumulative total. And 100% stacked area means it is best to show the distribution of categories as a part to whole where the cumulative total is very unimportant. Okay, so area chart, so it should be mainly depict this time series relationship, but they are going to be different in line charts, and different types of charts are available like area chart, stacked area, and 100% stacked area. So area chart which is going to be shown or compare the quantitative progression, whereas the stacked area which is going to be better best used to visualize part to core relationship, which is going to show each category contribute to the cumulative total, whereas the 100% stacked means which is going to be best used to show the distribution of categories as a part of 4, but when the cumulative total is unimportant. So what are the some design practices we have to be considered while designing this area chart? So mostly it should be make it easy to read is the first one. So normally in stacked area chart, they arranging the data to the position category with highly variable data on the top of the chart and lower variability on the bottom. So okay, so what is this highly variable data should be on the top and low variability should be on the bottom one. So that should be the design of the chart should be looks better, and start y-axis value at 0. Preferably many of the people are going to be considered this value should be not starting at 0. So preferably you have to be considered with 0, and don't display more than 4 categorical values. So if I'm going to be shown more than 4 number of categories, so what will happen, the data the image not looks like that much good here. So what is the data I'm going to be shown, that should be shown more than 4 categories, and use only transparent colors like in standard area charts. Ensure that the data what I'm going to be considered is not to be obscured in background by ordering uh, thoughtful and using transparency. And don't use the area chart to display the discrete data. So what is the data we have to be shown in area chart? That should be the continuous one, not that should be display the discrete data, not the continuous data. Our next one should be this scatter plot here. So the scatter plot is going to be showing the relationship between the items between the two sets of variables. Like they are going to be best to show the relationship in large quantity. So normally in revenue or by the product family. So if I'm going to be shown it, so I'm going to be consider the revenues in millions on the y-axis and the units sold on the x-axis. So normally the scatter plot is going to be show the relationship between based on the two set of variables, and this and the correlation between among the data should also be shown in the scatter plot. So what are the design practices we have to be considered in the scatter plot here? So start the value y-axis value at 0. So all the time this practice should be same. So what are the scatter plot we are doing, that should be start with 0 and include more variables. So in order to make the better comparison, and make use of the different size of different color to encode the additional data variables, and use the trend lines here. So this can able to show the relationship among the trends of the data, and don't compare more than two trend lines. Okay, so if I'm going to take more number of trend lines, so what is going to be there is it should be difficult to understand. So that what if I want to show compare the more trend lines, then it should be two only. And next one should be this as a bubble chart. So this is another kind of visualization which should be able to good for displaying nominal comparisons or ranking relationships. So the variations of bubble chart means suppose I want to show the relationship between the revenue versus rating. So where this should be almost all similar to this scatter plot where the with bubbles, but best used to display the numerical or additional data variable. So normally in scatter plot we can able to show on the dots here. So but in bubble chart we can show how much of size of the bubble it should be. If it should be less bubble, then it should be there should be have less preference. Suppose if I'm going to be big one bubble, then it should be best to show the additional value. So normally this bubble chart is going to be displayed the nominal comparisons of the ranking relationship. And bubble map is another kind of variation, so where you can able to show the visualization values for specific geographical regions. Suppose if I'm going to show this regions and the data where is going to exist in the map wise, then it should be I have to show in the bubble map. And another design practice is that so make sure the labels are going to be visible, and why because all the labels should be unobstructed and may easily identify with the corresponding bubble what it is. And the size of bubble should be appropriate one, so mostly it should be not that much size is going to be considered. So the bubble should be scaled according to the area, not the diameter here. And don't use the odd shapes as well. So avoid too much detail like using shape, and they should not be preferable one, and that is not going to be entirely circular and may lead to the inaccuracies also. Okay, so these are the some of the design practices of the bubble chart. And the very last one should be thus is heat map. So heat maps is going to be display the categorical data, and using the intensity of color you can able to show the represent the values of geographical areas or the data tables. So heat maps generally should be make different intensity of colors is going to be shown here among the geographical areas or the data table. So just now I'm going showing the states with new services contracts I can able to show like this. So, and what kind of relationship we have to be considered, and what kind of design practices we have to be considered for the heat map. So, use the simple map outline, not that much uh, uh, clumsy or details should not be shown. So, the line means to frame the data, not the distracting. And select the colors appropriately. So some colors stand out more than others, so giving unnecessary weight out to the data. So instead of that, you can able better to use a single color with varying the shades or the spectrum between the anomalous colors to show the intensity. And also going to remember the to code the color intensity according to values. So what I'm going to say that, so if I want to show this the data in heat map, it is not better, not suggestible to use the different colors. So same color what I'm going to consider, so make a vary in the intensity of this single color, it is better one. And next one should be use pattern spangling. So That means that so the pattern overlay indicates that should be a second variable is going to be acceptable here, but using multiple overlay and distracting one. Okay, so this dotted lines is going to show that I'm going to be including the second variable. Our next one should be the choose appropriate data ranges. So that means it is better to select more in between the 3 to 5 numerical ranges that may be enable the fairly even distribution of the data, not between them, and use plus or more signs to extend the high and then low ranges. Okay, so these are the some of the design practices of the heat map. So totally, I'm going to say what are the do and don'ts of the data design. So the designing the data that does not have to be overlaying, and so with the basic understanding how the data is going to data sets can be visualized, and so you can also be able to create more accurate and effective data visualization. So following these tips to ensure the data does not be a justice one. And do use one color only to represent each and every category, and do ordering the data sets using logical hierarchy, and do use catalogs to highlight the important or intensity information, and do visualize the data in a way that it should be easy for readers and comparing the values, and do use icons to enhance the comprehension and reduce the unnecessary labeling as well. And do not should be don't should be that use high contrasting color combination like red, green and blue and yellow, and don't use the 3D charts so they can able to skew the perception of the visualization, and don't add the chart junk which should be unnecessary illustrations and dropping shadows and uh, ornamentation distractions from the data, and don't use that more than the color of in a single layout, and don't use the distracting fonts of elements such as bold, italic, or underlined text like this. So these are the some of the do's and don'ts of the data design of the data visualization. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.